Hello and good time of day, everyone. Welcome to this new MLIR open meeting. Today we have Anton from University of Edinburgh, who's going to present a proposal for an MPI dialect. Anton.
Yes, hello everyone. I'm Anton Lüdicke. I want to present an MPI dialect for MLIR. This is not just my work. This has been cooking for a while at the University of Edinburgh together with some other people. So we, obviously Tobias Grosser, my supervisor, and the whole lab here in Edinburgh. And we also are working together with EPCC Edinburgh, and we have gotten some feedback from Jeff Hammond, who works at NVIDIA on MPI stuff. And so, yeah, so MLIR has proven itself, as you all know, an effective compiler that demonstrated the modular approach. The only thing is machine learning and most other workloads are scaling up, as we all also know. And so the obvious question is, do we want to try to support these ever-scaling workloads in MLIR too? And so the answer is obviously yes. Google, Node AI, and a bunch of other parties are all interested in seeing this happen. And so in order to do this, we're going the approach of bringing MPI to MLIR as like a fundamental building block first, and then building up from there. So yeah, and we've been experimenting with that a bit, and yeah, today we want to share our first little nugget. And so what is the scope and what is the ultimate goal for us? What we want to do is we want to participate, we want to contribute a bunch of small patches, all in, feedback with the community. I'm not an MLIR expert. And so we want to, develop this together, basically, in order to eventually get a very nice stack of dialects similar to what we already have for machine learning in MLIR. And as MLIR is, as we all know, very modular, we want this to integrate, flawlessly or as seamlessly as possible with the already existing dialects. And so, but yeah, this is the big vision, right? Let's keep it simple. We are currently on the very, very first patch, and we are looking for the very, very first feedback. And so, yeah, let's look at the very first patch. If I don't know how much all of you know about MPI, but if you open any MPI documentation or page or something, you'll see a very simple example, basically the MPI hello world. It looks something like this. This is C code. We have some message buffer. We have a variable called myRank. And what we do is we initialize the MPI context. We grab the current rank. MPI is commonly used in like single program, multiple data. And so every program needs to figure out where it fits into the whole scheme of things. And for that, it gets a variable, an integer, describing the position, basically. And then we branch on this rank variable. If we are process 0, we copy the message into our message buffer. And then we invoke MPI send, which does exactly as the name says. It sends some data somewhere else. In this case, we pass it the message buffer, the length we want to send, and the data type. We give it some information so it can find where it needs to go. In this case, we're sending it to rank 1. And we are passing it this magic value called MPI comp world, which is a concept from MPI for communicators. And here we are just using a global communicator that communicates with everyone else. Now, this sends the message out. And now we on rank 1 here in the other branch, we invoke MPI receive, which is basically the other end of the MPI send, which says I want to receive into this message buffer up to 20 of MPI character. And here we specify that we want to receive from rank 0. And again, we pass the MPI world. And so we receive this message buffer. The value gets placed in there magically through MPI. And then we can print the received message. And then we just have to do some housekeeping. We have to call MPI finalize at the end of every MPI program. So overall, it looks quite simple. It's just message passing. If we want to bring this into MLIR, our program would look something like this. And so we have 5 MPI operations here. So we create 5 MPI operations: MPI init, comrank, send, receive, and finalize. And yeah, okay. So let's look at what exactly we did to model these simple communication calls. I'm going to go through them one by one and quickly show you. So MPI init takes 2 pointer arguments. It's perfectly valid to pass null pointers. And so that's what the example does. It's the simplest possible case. And so that's what we want to model in the first patch too. So our first rule is we simplify default constant arguments. And so the MPI init operation in MLIR becomes this. So we have MPI init modeled. Then the MPI comrank. Here we could argue that MPI convert is a default constant argument. And so we omit it. And then we have out arguments. Here, my rank is passed by reference. This is an out argument. We just model it as an SSA result. Then we go on to MPI send. This is a tiny bit more complex. But again, we see a default constant argument. We have 3 arguments, a message pointer, a message size, and a message data type. We in MLIR land know this as a memref, and so we replace this with a memref. Then we have the MPI receive, which is extremely similar, except that we have this MPI status ignore variable. We just omit them for now. And so we get this very simple MPI receive, which looks just like an MPI send. And finally, we have the MPI finalize, which is trivially converted because it has no arguments and results. And so, yeah, this is already everything that we want to upstream in the very first patch. And yeah, to conclude, we want to start a series of contributions to MLIR that allow us to put it a little bit corny in the slides, to MPI send MLIR into the future so that we can, run on data center scale. This was already it. I guess some of you already saw this presentation at the LLVM Dev meeting, and I'm very happy to answer questions now.
All right, thank you, Anton. Let's move on to questions.
So you did the first few simple operations. My intuition would be that we would need to think ahead a little bit further to understand what things should look like.
Yes.
Or we understand what even send should look like. I don't know. Did you start thinking about it? Collectives and asynchronous?
Exactly. So there are quite a few very interesting questions. I was advised by Tobias to encounter these questions one at a time instead of, you know, opening a 2,000 line PR. And so we thought about it. We have an internal version of MPI with asynchronous sends and everything, but it's not perfect. And I would really like to step by step look into, you know, the first PR is like simple synchronous stuff. Then we look at how can we model communicators, or we look at how can we model asynchronous stuff. Yeah, in order to not, you know, end up in 500 little discussions at a single time.
That makes perfect sense. I wasn't disputing the upstreaming strategy. It was more just the thought process, right? What you're doing locally before you upstream stuff, that can be as much code at the same time as possible, right? Because you only have to deal with it yourself.
Yeah.
Yeah.
So for the
it's I was saying, I'm not sure I follow your strategy actually. I see a difference between like having small pull requests and incrementally implementing something and knowing what we will implement. Like those are two different things. Like having a design and an end goal in game and knowing how pieces will fit together and being able to discuss that is a bit orthogonal to we're going to start by a small pull request which just does the synchronous, then we're going to do this, then we're going to do this. And right now it's like I'm a bit surprised that you don't have more of a plan for collectives, for async, and for those kind of thing about indeed discussing the more meaty stuff of MPI.
There is an MPI standard, we developed some rules to look at like how we wanna follow the standard. But yeah.
So I think the point is it would be nice to have some sort of idea of a roadmap of how to get to a nice final solution. So not submitting a 5,000 line PR, but understanding how do we get to those 5,000 lines over many 200 line commits. Because it's hard for us to sit here and say, this looks like a good strategy without understanding how we're going to get to all the stuff that we know that we will need, right? MPI will be useless without collectives and asynchronous, that's for sure. And maybe it's all simple, but I can't judge this by looking at this, right? Need some more. So I think you guys have done some thinking, I guess. You said you've been working on it locally, so that this would be interesting to see what you've thought about, and I think it's worth it that you at least get to the point where you really have a useful set of primitives that you can use to implement real apps to convince yourself, and then secondarily everyone else that this is a good strategy that you chose.
Yeah, sure. That makes a lot of sense. I mean, I guess what we can do is we can what we wanted to do is share what we have relatively early. We could, like, behind closed doors, think about the best way we would implement collectives and think about the best way to implement asynchronous stuff. What we did internally was a scrappy implementation that just shows that it works. But I guess it's yeah, I'm happy to sit down and like properly write out basically the design document for the MPI dialect. Absolutely.
Yeah, it would be great if you can do that and send a proper RFC on Discourse for that. So some questions other question I may have is, like, you show example with memref. Is the modeling of MPI married to memref? What are the possible ways to represent those messages? And also memref is not necessarily dense. So
Yeah.
what is there?
Yeah, very good question. There are like two competing strategies. One is to follow the spec as closely as possible and basically have it pass it an LLVM pointer. We decided to use memrefs, and actually MPI has, so you pass the MPI the MPI calls triple. You pass it a pointer, a size, a number of elements, and a data type. And you can actually encode basically all memrefs in this MPI data type, because you can have strided data types. So I think I have
also in terms of use cases though, so I can, for example, say for a start that we do not have memrefs, we cannot get memrefs. So if we would use it, this would not be good enough. I think it's worth thinking about a more generic way of
Oh, okay, yeah.
how to pass buffers.
So you want to go directly from LLVM pointers, or?
Not necessarily, but at least it should. I think LVM pointers should at least be possible for it to be useful. Since you cannot always rely on people having memrefs. If you have a crappy input, which we have, then you're not lucky enough to have memrefs, and then you need to make do with what you have.
Yeah.
I would have thought that almost anything can be, any memory can be put in memref if you reduce it to a 1D memref of I8, for example. That should provide interrupt with almost anything.
Yeah, that could probably work for us as well. But that's also a good thing to discuss, right? If you have a proposal for this, you can say how this would interoperate with LVM and memory.
Yeah.
Yeah, I'll be happy to look at the proposal once you have some more stuff.
So one of the things was that we could like start writing an MPI dialect that mirrors 100% of the MPI library. I think kind of a not trivial to answer question is, what should the MPI RFC encompass, right? So like, where do you draw the line? And yeah, do we need like asynchronous? Do we need one-sided communication? Do we need collectives in the initial RFC, which is, yeah.
We can discuss.
Yeah, to me, it's not about the exact spec of the dialect. It's about categories, right? It's like you mentioned sync and async. So probably that, as you said, the first pull request would be just the sync stuff, but your RFC should likely touch on how are we going to model async later. We don't need to have the list of all the operators, but we need to know like what's the modeling. Are we going to use the async dialect in combination with this, or are we going to introduce a new async token specific to MPI? Are we going to, those kind of thing.
How will communicators work?
Yeah, exactly. Communicators is another thing. And you don't need to go through, like, it's not, we don't ask for a spec, right? We ask for concepts. And there are things where adding a new API is just adding a new op, right? There are things like that are pretty easy and straightforward, and we don't need to go through all the op. But there are things like async, which may require new IR constructs that are more, where there's more design discussion to have, and I think those are the points that are important to surface from the spec, and says like, here's what's in scope for the first steps, and here's what we think for the next step, and here are the design points that are still open for those kind of things that we know in the spec will require more thoughts.
All right. I guess giving like IR snippets, like this is how we imagine the IR to look like for the RFC would be roughly the right level of detail, or I'm just
Right.
like, yeah.
Yeah, with the trade-offs, you know, if there are multiple possibilities, or if you don't know about something, or if you have a good idea of what you want to do, why it's a good idea. Those are the kind of thing I personally would be looking for. I don't know about others. Johannes, if you want to.
Yeah, I guess I would like to be convinced that I can represent most HPC apps with this, which would mean definitely as asynchronous, definitely communicators, definitely collectives. I mean, if you're talking AI, it's all like all reduces. And then we can discuss one-sided, and there are infinitely many exotic features in MPI, but at least to the point where most sort of common applications would be supported. Not a proposal of everything like Mehdi said, right? But a convincing argument that we can support all of that and examples of how it would be done. Again, not in detail, but conceptually, how would should all of this be modeled?
Yeah, no, I totally agree. Yeah.
Yeah, I think the goal is making sure that there is no dead end, that we don't start something so that later we figure out we cannot finish. I think is the main thing. There was a question on the chat I'm gonna propagate here. So Chengji asked why the communicator in the MPI dialect is ignored and a default to use MPI world. It is possible that a model parallel program uses different groups, different communicators. So how do you see that? Maybe it was just your examples were too simplistic.
Yeah, exactly. Well, we had we were experimenting a while, like how big to make the initial PR, and we decided to drop support for communicators in there, but it's definitely a thing that will be added relatively soon, I would imagine, and it will definitely be in the RFC. How we imagine one could use communicators.
I see a hand raised. I take it.
Yeah, hi. I have also one question. On the shown MLIR code, it was quite similar to the code when you, for example, have an MPI C program, get from there with C guys to, let's say, core MLIR, and then replace fun calls by like MLIR operations, let's say. So my question points towards, like, will it be part of the scope of this project to transfer or have compiler passes getting from, let's say, such representation with fun calls from MPI API calls to the MPI dialect?
Yeah, very good question. I think that's definitely a possibility. The difficulty would be that if you, how do I put it? If you would translate an MPI program into MLIR code, you would have your function calls would look a little bit weird, because MPI uses a bunch of specific data types that I don't think C guys would properly translate. So you would end up with like opaque struct pointers instead of MPI communicators, etc. But yeah, absolutely, that's a relatively simple path to implement.
Yeah, exactly. Like when I played with that the last days, I had the same problem, like as you pointed out. But maybe at least for a subset of programs, this should be possible, I guess. But yeah, one needs to analyze this and really to point out what's possible, what's not. But yeah, but definitely, I think it would be worth to look into this and write out or like together maybe what we can do, what's possible, and so on.
Yeah, it's very interesting because like optimizing MPI programs is pretty difficult at C level. And so raising them into MLIR might enable smarter data flow analysis and stuff. This is one of the things we are very interested in too.
So that's also something I'd be interested to see in the RFC, because MPI is not a very high level API to some extent, like when you look at the pointers and things like that. And one could model this with just function calls. And so if all it is, it's a library where we call, like we pass pointer in and we call functions, these questions why we need a dialect for that. So the real point of a dialect is to support transformations in a compiler, support higher level modeling. It's being able to reason about something in a way that we can't with just function calls. And so that would be also probably an important point. We had a hand raised, but I don't see it anymore.
Yeah, I raised the hand, but I was just going to make the point that you just made, that the current idea or the current proposed API, it just looks like something which, for example, the GPU dialect does to generate GPU calls, where it just has a bunch of execution engine wrappers, which simplify the APIs that it actually needs to call. So it would be interesting to see how having it as a dialect and not just as generated like function calls would enable some transformations, or it would make it easier to work with on the MLIR level and so on. Yeah.
I guess part of the reason is, or the biggest reason is that MPI is a spec for a C header file, and it does not actually describe a stable ABI. And so you can't have just function calls that that are as general as the MPI dialect would be. So if you want to generate function calls, you would already need to know which MPI library you would target. So it is an abstraction level above that, basically. Kind of like, I don't know. I don't know the exact details, but like if your GPU dialect would have like multiple different implementations of these functions with slightly different signatures.
Yeah, that is like currently implemented with the GPU lowering pipeline. They have like the MLIR specific wrapper API, which then delegates the calls to the different implementations. But yeah.
Yeah, exactly. Another
but it would be interesting to have something more than just that. Is my point.
Yeah, Fabian Mora put up an interesting point in chat that an MPI dialect would allow us to verify MPI programs a bit better than just having function calls. So yeah, there's a lot of neat little things that are not very obvious that one gains from having an MPI dialect. I can definitely write them up in an RFC.
That's exactly your job, I think, to find those convincing reasons why this is beneficial to have. You could also argue that you need a general, collective communication dialect, which is not modeled after MPI, but that you can lower to MPI, for example, right? Why is MPI the right level of abstraction for us?
All right.
Maybe I have another question for you. You showed a usage of the API on memrefs, which matches pretty well the library vision of MPI. What about the tensor level? Like, would there be a way to express communication and things like that, collectives, in a immutable value world, or would this not be MPI anymore?
Very, very good question. So MPI inherently works with buffers internally. So you at some point need to step away from that. But to it is definitely on the roadmap to have a higher level message passing dialect on tensor semantics, where you can then use the better semantics to do like much easier optimizations for message passing than directly on MPI.
But from your point of view, that would be a different dialect. That would not be called MPI.
Yes, because that would live on some higher level, I assume.
Okay, it's worth calling out in your RFC also that you thought about it and you exclude it intentionally and punt it to a higher level dialect.
Yep.
And it's going to be particularly interesting to see how it connects to the mesh partitioning that Cheng-Jie has been working on and others. And so that's why the high level, connecting the high level to the low level is going to be interesting, seeing how bufferization is going to go through and this kind of thing.
Yep.
Hello, can you hear me?
Yes.
Yep.
Yeah. So I have a question, because it seems you want to kind of strictly follow the MPI standard, or as strictly as possible. So have you encountered like some concepts there that are would be kind of difficult to replicate? Like that.
Yes and no.
Okay, can you give us
MPI
like
has
some examples of stuff that you think it's unclear, and yeah, that basically would be kind of the difficult part.
MPI has a lot of unintendedly weird behavior that would be very difficult to model in MLIR. For example, MPI allows you to send 10 ints, and then on the receive side, you request a receive for 30, but you will not get 30, you will just get 10. And you can also encode like absolute pointer values in MPI data types. There's lots of weird behavior that is normally unwanted in MPI programs, or maybe not always unwanted, but that is like fringe to MPI. That would be difficult to map to MLIR just because, yeah, it's C, right?
So you don't think it's would be appropriate like to have, because API has the interface to create like these custom data types you mentioned, where you specify what stripe you have there. Like I don't know, it's it seems like the surface area that the API standards is very big.
Exactly.
And yeah, so for example, because you would probably want this, like definitely want something like to be able to model strides there.
Yeah, I have I prepared a slide just for this.
Okay.
1 second. Here, where we have a memref subview that we want to MPI send. And so you have like this MPI vector type thingy, which we can also definitely expose more freely if we want to in the MPI dialect.
Sorry, I cannot see. I don't know if other people also I see a blank screen. So other people also see the blank screen.
Yeah, it's a blank screen.
Oh, interesting. Is this better?
Yeah, now I can see it.
Yeah, here we have a memref subview that we are MPI sending, and where we then construct an MPI vector type.
Okay, so I have another question. Could you in your Hello World example, you had like MPI in it as part of the MLR program. So you usually you might find yourself in a situation where in one program you may have some code that's being compiled with MLIR, then other parts also want to use MPI. So have you thought about how they would share these primitives like communicators? Because I imagine something like you would be able to somehow initialize the MLIR part with somewhere else. You initialize your the MPI context, and then you create communicators, and you're able to pass them to the program.
Yeah, MPI communicators will definitely be SSA values at some point. And so you can just have them as function arguments if you want to pass them around. And so at least the way I foresee it, you would do it like you would interoperate with like other libraries or MPI using code bases the way you do it right now too, by like passing around these MPI data types.
Okay, so like if I have a communicator as an argument, let's say to a function that gonna be like part of the interface of the MLI program, it would end up like as a opaque pointer or something like this. And
yes, so it would depend on your MPI library, but yes, you would end up lowering it to some LLVM thing, just like everywhere else. Yeah, just like in C, for example.
Maybe I can continue with another notion. Have you thought about, like, until now we talked about like all the API calls from with MPI and so on, but I think there's also like a crucial part that MPI or the concurrency that MPI is inducing. And for example, if you have a if statement or if region which is based on the rank, as you showed on your example, that this could be seen as like so two if regions could be seen like as SPMD regions, and which are like in parallel and so on. So my question is, makes it sense to go this step and really introduce then this parallelism into the dialect, or do you really want to stay on the level, okay, I have API calls and want to get them into a dialect? I don't know if it's clear what I want to say.
Ooh, very, very interesting question. So far, we tried to just model the library, but I think looking into like an SPMD dialect, I guess that would be its own dialect. I'm not sure, but that sounds like interesting, but only slightly related work. And I don't think I want to do that as part of the MPI dialect. But yeah, very interesting idea.
Can you hear me?
Yep.
So I already mentioned you this, but something that if you have an answer now, or if you put it in the RFC, that's okay. But have you thought how are you gonna lower this into API calls? You mentioned that different libraries have different ways to do things. And I remember telling you that one option was having like a wrapper library, like in the GPU dialect. So instead of having to go and do different lowers for impeach or for the MPI, you can have a single lowering path. Have you thought of that? And if not, it would be great to have it on the RFC.
Yeah, very good question. I implemented a lowering to both MPIC and OpenMPI. They are like the two biggest competing, or not competing, library implementations, just to like prove that it is possible. There's also Jeff Hammond just finalized his MPI 5.0 proposal for a stable ABI. So these are the three options that we really looked into and verified that all three of them work. I'm pretty sure that we could also add an MLIR runtime library that would take care of selecting them. And yeah, there is quite a bit of other example implementations that already abstract away the differences between the ABIs. I can definitely put that in the RFC. Very good point.
Next, we had a question on the chat. I'm gonna just repeat it here from Chengji. Have you considered how to convert a traditional collective communication library, something like stable HLO or Radius, to an MPI or Radius? Thinking the most difficult part may be how to map the high-level replica groups to the MPI communicator. So that comes into how to model the communicator, I guess.
Very interesting question. I have not looked into that specifically, but I would be very, very interesting to see how exactly these replica groups are set up. I tried to do some research into the stable HLO parallelism stuff, but it is, at least for me, it was quite difficult to find documentation. So I will get in touch about that.
Hopefully that's answered, Chengji. In the chat, Anton, you have more information, a link to the TensorFlow documentation on operation semantic for all Radius.
Yep. Thank you very much.
It may be also connected to what I was saying earlier, that we have some work in progress for the sharding mesh dialects and representation on tensor of sharding over multiple devices, multiple nodes. And the lowerings of all of that and the mapping to MPI would be interesting.
Yeah, absolutely. I assume that it should be possible to map these to MPI calls pretty easily. But yeah, it would be interesting to figure out an example in detail. Absolutely.
All right, any more questions? we're gonna leave it here 10 minutes early. Oh, there is one hand raised. Go, Chengji, if you can unmute yourself.
Oh, yes, it's actually not a question. I just want to say that between mesh dialect and here the MPI dialect, there should be a CCL dialect in the middle between them. And so what I was just asking about is that how to roll a CCL dialect to MPI dialect. And if you want to run them, we want to compare mesh dialect and MPI dialect together and run them end to end. Maybe, yeah, we should also consider put a CCL dialect, maybe upstream. And yeah. So that's what I want to say.
Yeah, I guess it would be.
You have this plan or Anton, you have the plan of CCL dialect?
I'm not sure. This is the first time I hear of a CCL dialect, but I guess having a CCL style dialect would definitely make a lot of sense. As I was saying previously, I guess a communication dialect that is somewhere between like very high level and very low level, that works on tensors and is like relatively specific about what data it is sending where, would be very useful for optimizing.
Yeah.
I guess that could be the CCL dialect.
Yes.
All right. I think that's going to be it for today. Thanks again, Anton, for the presentation and all the discussion. I'm looking forward to the RFC. I think that was a productive discussion to make this RFC probably very much better also. Thanks everyone for attending, and see you next time.
Thank you. Thanks for organizing.
Yeah, thanks everyone for showing up and asking all these interesting questions. Yeah,
You have some work to do now.
Yes.
Right, take care. Bye.